Good afternoon. We are ready to go today with notes for 3.2. So if you would go ahead in your notebook, this is where your notes are, if you would go ahead and pause the video and take a moment to complete this form out. It'll just be a check of what we did on 3.1. So go ahead and pause the video, work this problem, and you'll restart it. So your answers for this, hopefully you've worked them out, just to make sure you're on the right track. These are your two answers that you should be getting. So the first one, you should be using A equals P parentheses 1 plus R over N to the power of N times T. On number 2, you should be using the PERT formula. Make sure that you are changing your percent to a decimal, and that if you're needing to do it on your calculator, you are putting your exponent in parentheses. So today we're going to be talking about logarithmic functions. So your two objectives are to be able to change between logarithmic and exponential form, and then to be able to evaluate and graph logarithmic functions. So if you do not have out that graph paper, you will need it out. For the remainder of this, you actually will not use a calculator, but you will need that graph paper that I gave to you on Friday. And again, you have access to the stapler and the tape up by where we get our warm-ups or where we come in the door on that cabinet if you're interested in doing that in your notebook. So that you have the graphs and you don't have to worry about where they are. So you'll want to pause the video and take a moment to write this down. This particular expression is talking about the change from a log base b of y equals x to exponential form of b to the x equals y. In both of these cases, what we're doing is we're just talking about changing from one form to another. So you're going to see logarithmic form on the left that has a log with a base and then something after it. And then you're seeing exponential form on the right where you have a base with an exponent equal to a number. So notice that the bases are the same in both of those. Notice the location for log base b, it is a subscript. And then notice that the x and y kind of switch locations of the equal sign, and the x becomes an exponent on the exponential form, whereas on the logarithmic form it's after the equal sign. So we're going to be talking about how to switch from one to the other. So as if you're not done writing that, you'll want to pause and do so, and then start again because I'm going to move on. Our first example is to be able to rewrite an exponential form. So if we have 4 equals log base 2 of 16, really this first exercise is just making sure that you know how to change forms, because we will use it to graph, we will use it to solve equations, and we will use it to evaluate. So all we're doing is we're starting with the base. So if the base of your log is 2, the base of your exponent is 2, then you're going to go to the other side of the equal sign, so to the power of 4, and then it's going to end up being equal to what comes after the log. So 2 to the 4th equals 16 would be exponential form. In exponential form, you should know that 2 to the 4th power is indeed 16. So if you said 2 to the 16th power equals 4, that would not be an equivalent equation. But you have to recognize the logarithmic form as well. So you go ahead and try the second one on your own. You could write it down. And you may have to pause periodically through this, but I'm just going to go ahead and kind of work through it, and then you can check your answer. So you should be getting 7 to the negative 2 power equals 1 over 49. Remember we talked about previously that a negative exponent means that you would basically do the reciprocal of 7, which would be 1 over 7, and then to the second power, which would be 1 over 7 squared, or 1 over 49. So the next example, for example 2, is asking us to rewrite in log form. So now we're changing from exponential form to logarithmic form. And so again, as we're doing this, 2 to the negative 4th equals 1/16. We know that to be an equivalent equation, or equivalent expression. So here we're going to do log with our base. Our base of our exponential form was 2, so our base for our log is 2. And again, you want to make sure it's a subscript. Then you go to the other side, which is 1/16. And now it's going to be equal to the negative 4, because again, 2 to the negative 4 is 1 over 16. So just kind of check your answer there. Okay, so you are still going to the other side. Log base 2 of 1 over 16 equals negative 4. And you're writing that. The last one, rewriting that in log form, 12 squared equals x. So go ahead and rewrite that, see if it matches my answer. So you should be getting log base 12 of x equals 2. And again, just check it. Base to the power on the other side equal to x. 12 squared equals x does match what we originally had. What you should be noticing is that throughout all of these, if I kind of do some highlighting here, so you can pick it up what I'm saying, if we have 12 squared here, it's not going to be 12 squared. It doesn't look like 12 squared if I were to cover up the log. The 12 is on the left, the 2 is on the right. And that's because logs and exponents, the reason they're in the same unit is they're inverses of each other. And if you recall from previous units, inverses are whenever we switch x and y. And so that's kind of what's happening here, is we're switching those, and so they're not going to be next to each other when you rewrite the forms. Okay, next one is where we're going to take out our graph paper. And so we're going to talk about the difference, again, between these exponential and logarithmic graphs. And so this is where we're connecting this idea of inverse functions. So we're going to graph f of x equals 2 to the x, which is the same thing we graphed in the previous section. So I went ahead and I gave you this table. This was the same table we created in 3.1. So remember, we're just subbing positive and negative numbers in for x to come up with the y values. And then we're going to figure out how to do g of x, which is log base 2 of x. So these are relatable functions. Remember, you can change f of x to be y equals. So we're talking about y equals 2 to the x. And then y equals log base 2 of x. Now, one of these is obviously an exponential form. One of them is a logarithmic form, but they're actually two different functions. Since they're definitely set equal, or since they are set equal to y on these, this first one is going to look like what we're familiar with from before. So negative 2, 1/4. We can go through and graph each of those. Again, if you need to pause in order to do that. So we're going to make a nice smooth curve. We're going to approach the horizontal asymptote, which is not yet on my graph. We should recognize that the horizontal asymptote for this exponential function is at y equals 0. So we talked about the domain would be from negative infinity to positive infinity, and the range is from 0 to infinity. So that's a little bit of a review from what we did before. As we're graphing a logarithmic function, this form that we're seeing, y equals log base 2 of x, probably many of you, or maybe even all of you, would struggle to come up with a table for that. But if we just change the form of that, and we try to write that form in exponential form, we would start with a 2, we would take it to the other side, and it would be equal to our x. So 2 to the y equals x. So now, if you compare 2 to the y equals x to 2 to the x equals y that we had from the previous equation here, what's happened is that the x and the y's have just switched. Okay? So you want to definitely recognize that. Here we have an x, but now the x is after the equal sign. Okay? Our y was before the equal sign or after, where you can switch the order, and here the y is in the exponent. So what you want to recognize is that what is isolated by itself and what is in the exponent have been switched. That's what happens with inverse functions. We switch the x and y and we solve for y. So what this is saying, when we have 2 to the power of x equals, or 2, to the power of y equal to x, now instead of plugging in numbers for x, we would plug in numbers for y, because that's what makes sense in our exponent. So we would still plug in negative numbers and positive numbers for y. So we do the same thing, but now we're going to take 2 to the, let's start with 0. 2 to the 0 power would be an x value of 1. 2 to the 1 power would be an x value of 2. 2 squared would be 4. We do the negatives as well. 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. So what you should recognize between these two tables is that we've switched x and y. -2 1/4 went to 1/4 -2. -1/2 went to 1/2 -1. So as we graph the second one, we would have 1/4 to -2, 1/2 to -1. Now we have an x-intercept instead of a y-intercept. And then we could graph the remaining values. We would connect them to make a nice smooth curve again. And now instead of having a horizontal asymptote, hopefully you could realize what kind of asymptote we would have here. In this case, we would have a vertical asymptote because it is approaching 0 on the x. So now we have an x equals 0 because again, we're switching x and y even in the asymptote. And so if you recall, inverse functions are reflections over the line y equals x. So I'll graph it in yellow. It's going to be kind of hard to see on this yellow graph, which is good and bad. But if we graph y equals x, we would see that they are reflections over that. Okay, so approaching asymptotes. So if we go back to the domain and the range, the domain, as you read from left to right, now starts at 0, goes to infinity, and the range actually is everything. It goes from -infinity, and even though it's pretty flat, it does keep increasing. So -infinity to +infinity. So again, these have switched. The domain for exponential went to the range, and the range for exponential went to the domain for log. Okay, so everything is switched. We're just switching. Basically, x and y are switching back and forth. So you do need to be able to do that without a calculator when it comes time for the test. On your homework online, remember it's going to be matching, but it's going to be translating those. So you need to be able to translate that logarithmic graph. So that's what the second one is. It's asking you to graph this function y equals log base 4 of x plus 3. So what you want to do is recognize the parent function to be anything before you translate or reflect. So y equals log base 4 of x. That would be our parent function. If we change the form so that we could create a table, we would have 4, which is our base, to the power of y equals x, which means we would start plugging numbers in for y. If you're doing the parent function for an exponential or a log, there's no reason to pick different numbers but those 5. We would sub those numbers in. 4 to the -2 would be 1 over 4 squared, which is 1/16. 4 to the -1 is 1 over 4. 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. Obviously, all of those will not fit on a 10 by 10 graph. Okay, but that is our parent function. Now, we're not done. This is not saying this is not our parent function in our original. We have to take our parent function and shift it. Think about which way you shift that. So you're thinking left 3. So as we graph our parent function, we're not going to be able to graph 16, 2. Remember our asymptote is at x equals 0. So there's my parent function sketch. We're going to take all of those values and move them left forward. So we were here at 1/16 -2. So if we go back 4, we're almost to -4, not quite. Same with -1 or -1, 1/4 -1. We're going to go back 4. 1, 0, back 4. And then 4, 1. If we go back 4, we're going to get 0, 1. Remember our asymptote for our parent function was at x equals 0. That's where the parent function asymptote occurs. So we're going to shift that back 4. So that's going to end up at x equals 4. And I encourage you to graph the -4, excuse me, to graph the asymptote before you graph the function so that it can approach it. And we're going to do our best to make a nice smooth curve. It's not going to increase very fast. It's still increasing over here on the x values. These are still going up, but they're going up ever so slightly. And if we're looking at our domain are our x values. If you read it like a book from left to right, it's going to be -4 to infinity. And then our range is going to be negative infinity to positive infinity because we're looking at the y values. So there's another graph that you have of log functions. So as we kind of get into this, we're going to have to be able to evaluate without a calculator. So you might not even write these down because we're going to do some more in a moment. But what you need to start seeing is just kind of how logs and exponents are related. So if we have log base 2 of 4, what you want to start seeing is, okay, I'm trying to figure out 2 to what power is equal to 4. That's really what we're doing, because we could set this equal to maybe what we don't know. We're trying to evaluate it. So 2 to what power is 4? We know the answer is 2, because 2 to the second power is what's equivalent to 4. So we're looking for what would be after that equal sign. Okay, another one, just to try to get you more comfortable with these. Again, not even needing to write them down. Log base 3 of 9. Just start thinking, 3 to what power is 9? You should start be able to come up with 2. I give you another one. Log base 5 of 5. Ask yourself, what would be the question you would ask if you were changing that form? The question should be 5 to what power gives us 5? And you can write it down. 5 to the first power gives us 5. Another one. Log base 5 of 1. Question you're asking yourself, 5 to what power is 1? Anything to the 0 power is equivalent to 1. Maybe, again, not necessarily needing to write these down, just trying to see if you can come up with the answer. Log base 2 of 8. Maybe log base 3 of 81. Maybe log base 2, the harder one here, is 1/4. Okay, what are those equal to? So if you want to pause a moment and just think about those, or as I say it, you know them, okay, then you're really starting to get this evaluated. 2 to what power is 8? If I go back up here to E, 2 to what power is 8? You should be able to think 2 to the third is 8. 3 to what power is 81? Well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that took 4 3s. So 3 to the fourth is 81. Here we have 2 to what power is 1/4? You should be able to start thinking about what that exponent should look like. Okay, 2 to the 0 power is 1. Anything to the 0 power is 1. So if we're getting 1/4, which is less than 1, the exponent has to be less than 0. If you think about it, remember if we take a negative exponent, it gives us the reciprocal. So it's going to have to be negative. So 2 to what power is 4? That's 2. So 2 to the negative 2 power is actually 1/4. Okay? So we're going to see some more of those in a moment. See if you're kind of understanding those. Okay, this particular slide is talking about the difference between common logs and natural logs. Common logs have a base of 10. Natural logs have a base of e. So you're not going to see log base 10 of x written very often. You're going to see instead log x. So that is assumed to have a base of 10 right there. They're just not going to write it. So you're not going to see it. Okay, it's just going to be written log x. The same with natural log. Remember, e was above natural log? Well, 10 to the power of x is above log, common log. So a log base e is going to be read ln of x. So that means you have a base of e on your log. So on page 407 and 409, they just give some properties of logs. Okay, there's some for log base b, there's some for natural log. Remember again, natural log is log base e. Okay, it's that Euler number. And so you're going to see some of these, some of which are helpful to know. Some others you can just find by changing the form. Okay, some things at the bottom, that these last two on each column are really helpful to know because you start seeing that the base of the log matches the base of the exponent, so they cancel out just to give you the exponent. The base of the exponent matches the base of the log, so it cancels out just to give you what comes after the log. The same thing here. Remember, these are base of e. So ln e is log base e of e to the x, so they cancel the log and the e. log base beginning, and the same for the last one there. So recognizing some of those special properties, they are going to be really helpful. So if you need to pause that to write those down, then I would encourage you to do so. So the last thing we're going to do here, we're going to do a couple more, 5 or 6 more evaluating without a calculator. So these are like what I mentioned earlier that you didn't necessarily need to write down. So kind of going through these and seeing if you can get them. So I'll give some wait time in my video. So hopefully in the amount of wait time that I give, you were able to at least think about what it is and also write it down, of course. So I'll try to provide a little bit of wait time here so you don't have to pause so often, because I'm sure that can get annoying. So the first one is log base 2 of 16. So we'll give you about 15 seconds to try to come up with that and write that down. So 2 to what power is 16? Hopefully you were able to come up with 2 to the 4th power is 16. That is our answer there. So the second one, log base 7 of 1 over 49. So we should recognize that since we have a fraction, it should be a negative number. 7 to what power is 49? 7 to the second power is 49. So 7 to the negative second power would be 1 over 49. It would be 1 over 7 squared. Next one, log base 25 of 5. This one's definitely more challenging. Okay, if you're not getting this one might be one that you really do want to rewrite it. Okay, so 25 to what power equals 5? Well, again, if we kind of think about what we know, 25 to the 0 power is 1. Well, this is obviously bigger than 0 then, because I'm getting a 5. So 25 to the first power is 25. So since 5 is in between 1 and 25, my exponent should be between 0 and 1, which means it's a fraction less than 1. So you want to start thinking about, well, how in the world can I get 5 from 25? And maybe you're thinking the square root, hopefully. Well, the square root of 25 means it's 25 to the 1/2 power. So the answer here is 1/2, which is between 0 and 1. The other way you can think about this is try to get the same base, which we're going to use to solve equations. 5 to the second power is 25. So you could put like a X on that in place of your question mark. And 5 to the first power is 5. So if the bases are the same, then the exponents have to be equal. So if 2x equals 1, and you divide by 2, you are going to get x equal 1/2. So if you took 2 times 1/2, you would get 1. And so you 5 to the first equals 5 to the first. That's what you're looking at there. So here's another radical. You have to start to consider log base 2 of the 5th root of 2. So I'm just going to go ahead and work this one through with you. And maybe you feel like you already have it, so you're great to go. What I would encourage you to do here is to change it so that it's 2 to a power. Remember, the square root is the 1/2. We just talked about that. So the 5th root is the 1/5. And then you could change the form. So you could say, okay, 2 to what power is equal to 2 to the 1/5? And you'll notice that the bases are already the same, so this has to be 1/5. The other thing you could notice is that log base 2 of 2, that's one of our properties from before. Log base 2 of 2 is this property here. And so your answer is what you have in the exponent, because your base matches for both the log and the power. The last couple here, so E is log of 100. Again, without a calculator, you have to recognize that that is a base of 10. So log of 100. You're asking yourself 10 to what power is 100? Good news is that we're just doing multiplication or adding zeros on there, so 10 squared would be 100. So again, you could rewrite it log base 10 of 10 squared And so the base would cancel that out as well. So the last one here, e to the natural log of 125. Again, remember you can write this as e to log base e of 125. Okay, or e to the natural log, and you could put the e there if that helps you. So these are going to cancel each other out. Okay, because the base here matches the base here. Base of the power matches the base of the log. So the answer here just is 125. And again, that's another property that we wrote on the previous slide. So that is it for logarithmic functions today. Again, a couple things to remember. How to change back and forth from one form to another is going to be critical. Being able to evaluate logarithms without a calculator, and then being able to graph, recognizing that logs and exponentials are inverse functions. So now you can begin your homework for 3.2, or if you haven't finished 3.1, that is due tomorrow as well. Have a good day.